Right. So now that we've seen all these supervised learning algorithms, especially the neural networks, and also since we've covered the data engineering and feature engineering methods, especially in the unstructured setting, now is a good point to actually get our hands dirty with doing a small kind of activity, or a mini project, if you will. And for that, I went to Kaggle and I got this particular data set. So this is called a Pokemon image data set, where it has a bunch of Pokemons. It has all the Pokemons, and the types of the Pokemon is also present in the data set. And what we are interested is in the images of these particular Pokemons, and those are also present here. So you can have a look at it by going to this particular link. So I've downloaded that. I downloaded it, and then I took all the the ice type Pokemon and the bug type Pokemon, and I've put them in separate folders as so I have this folder called Pokemon Bug or Ice, and in bug I have all the bug Pokemons that were in the data set, and then in the ice type I have the ice Pokemons. And our task now becomes how to classify. So the input is the image to my neural network, and I want to do some image classification on this. So how do I classify between bug type and ice type? So we'll have a look at that in orange. You can try to emulate the same example, or you can take a bunch of categories, put them in folders like I showed you, and do your own in-home mini project. So for that I go to image analytics first, and then I go to import images, and then I choose the folder where my images are present. So that would be here. Yeah. So this is that, and to just ensure that your images have loaded in properly, you can use the image viewer widget, which gives a small sample of your images. So you can see that it has been loaded properly. So these are the bug Pokemons. If I scroll down, I have some ice Pokemons. So all these are there. Now what I am going to do is I will first get some embedding. So embedding is just a complicated name for saying I want numbers out of my picture, right? So what this does is it uploads my pictures to this Inception v3 model. If you don't have an internet connection, then perhaps you should use SqueezeNet, but Inception v3 gives good performance. But basically this just converts all your pictures into some raw number values. So we saw pixel values as one possible embedding of pictures, but so there are more advanced models which gives better numbers that kind of describe what your picture is. Now in the case of Inception, it gives us I think 2048 numbers for every image, and we can later use those numbers to actually perform our analysis on. So if we look at this particular output, so here we have some 2048 features for each of our pictures, right? For each of our pictures, these are the Pokemon names, right? So we have this, and now what we'll do is we will now fit a neural network on that, and before we do that, we'll use this widget called test and score. So here in this, since we've already looked at cross validation and also how you can compare two separate models, we'll create two neural networks now. So my first neural network is you can feel free to play around with this. For example, here I can say add some 50 hidden layers, so 50 layers. If I want another layer, I can separate it with a comma and then add another layer also, which hopefully may also increase the performance. Say I'll put 6, and then I'll say you can play around with any of these. You need not know what they do to actually use them at the end. So perhaps I'll do relu and Adam, and I leave this here, and then I'll also initialize another neural network. Say for this I'll just have one hidden layer with some 100 neurons, and then I'll leave them just like that. And what I can do is now I can connect these to test and score like this. And then what test and score does is it will take all my input models, it will perform cross validation on them, which is a good way to check if your models have fitted or not. Because if you don't perform cross validation, if you simply test on your entire trained data, your neural network can overfit, and then even though it would give good results on your training data, it probably means that it has just memorized all your data. So that is one kind of thing you can run into. To prevent this, we use this method of cross validation to get a more robust estimate of how good our models are on generally on the data set and also between each other. And when we do this, we see that we see the first neural network that we had, which is I think the 2 layers with 50 and 6 with these particular attributes, seem to have performed better than the other one. So we are interested in just the classification accuracy, and we can see that the first model got an 83.2% accuracy, and the second one is just 80%, which is just marginal but good enough. So we will consider this network, right. So now through test and score, we can see where our model has actually made certain misclassifications or mistakes. So for that, I'll use this widget called confusion matrix. It's called the confusion matrix. It's not that confusing, but basically what we have is the following. We have a predicted class and an actual class. So our model, given some input, is predicting. So if my input were bug, right, and if it also predicted bug, it happened in 64 cases. So I have 64 plus 8, a total of 72 bugs, and out of the 72 bugs, I have predicted 64 to correctly be the bug, whereas on 8 of them I've had some misclassifications. So we can have a look at what happened and also try to predict why it happened this way. So now if I just select the 64 number, which is all bugs that I have classified correctly, and then if I put this through image viewer, now it will just show me the bugs that I have actually classified correctly. So all these my model has learned to correctly classify them as bugs. So this is there, and also these are the Pokemons that my model has correctly classified as ice. So we see that most ice Pokemons are kind of blue or purplish. I'll also put the title to be the image name so that we know what Pokemon these are. Most of these are kind of bluish. This is the Jinx Pokemon has a purplish shade, but it is a nice type. If I go to bug, then you can see I have these are more yellowish colors. So I'm only looking at colors, but the model also may look at the shape of the Pokemon and all that stuff. For example, most bug type Pokemon seem to have wings, and perhaps the model has learned to learn that as well. If you look at the misclassifications, which is more important, interesting, we see that these Pokemon, so since I selected this, my model has predicted those to be ice Pokemons, but they actually turned out to be bug Pokemons. So those are this. So we see that these Pokemons are supposed to be bug were predicted ice. We are not sure why yet, but that is the behavior of our model on this. Whereas when we look at the other side, where we've actually predicted ice type Pokemon, certain ice type Pokemons to be bug type Pokemons, we get these, right? So we are just looking at the pictures and not the names, but this is kind of the behavior you get. So right, so since we've covered so much, you can try to use your own images. You are not just constrained to 2 classes, you can use multiple classes, and I hope you build more interesting things in Orange using this kind of setup. Right. So in this module, we covered how to import your images, how to get embeddings out of these images, how to perform cross validation on them, how to compare 2 models. So it should be here. How to compare these 2 models in our in this widget. And then I can select one of these to pass in through to my confusion matrix, and then later look at the images. If you are interested in the other model, you can just select your learner over here and see. So that's it for this particular video. I'll see you soon in the next ones. Thank you.